What's up, guys? I understand that factoring can be hard to understand. There's a lot of things that go into understanding factoring, a lot of practice that goes in to really understanding what you're trying to achieve. So what I did is I wanted to create this video for you that not only goes through the basics of understanding what we're trying to achieve, but also go through some examples so you can see step by step how to factor trinomials when a is equal to 1, when a is not equal to 1, when we're dealing with fractions. It all goes through the basics as well as through the most advanced. It's all in this video, and I hope you enjoy. Cheers. All right, welcome ladies and gentlemen to the first video in factoring. And guess what? We're not gonna get into traditional factoring, but trust me, stay with me here. This is very, very important because when students start to get mixed up on factoring, immediately I have to go back and review with them exactly what we're gonna cover in this video. And that is going to be finding the factors as well as the prime factorization of a number. So there's a couple bit different things, definitions that I want you to know now as well through the rest of the course. There's two terms that I think are gonna be most important. One, factors. Factors are numbers that evenly divide into another number. Factoring is the process of taking an expression or a number and rewriting it as a product. So there's two things we're gonna do in this video. One is we're gonna go back to prime factorization. And prime factorization is basically taking a number and rewriting it as a product of its prime numbers. Prime numbers cannot be divisible by any other number except for 1 and itself. So when we're dealing with factoring and we see like a prime number, that should also be a clue of like, there's not gonna be a lot of options that I'm going to have to think through on my own. So let's go through a practice with this and just kind of understand factoring, prime factorization, and then finding the factors. So for prime factorization, there's a couple tips that I always like to help students out with. Actually, I'll get to that in number 4. So when we're trying to factor a problem or a number down to its prime terms, what we're simply looking to do is breaking it down. So we say, all right, can I rewrite 8 as a product? And you could say, well, a lot of students will say, what about 4 times 2, right? And that is correct. That we have now factored the number 8 because 4 times 2 equals 8. That means 4 divides by 8 2 times. 2 divides into 8 4 times, right? You see how the factors and factoring kind of works? However, this is not the prime factorization. If we wanted to write the prime factorization, we would need to break this down further. Well, 4 is what we call a composite number. That can be broken down into 2 times 2. And 2 is a prime number, so we can just rewrite that as 2. And again, notice 2 times 2 times 2 is going to equal 8. That would be the prime factorization. So this is just a good practice of breaking down numbers, getting used to what are the factors that divide into our numbers. Because for factoring, understanding that having that number sense is so critically important. Let's do one more. If I was going to take 24, just think of any two numbers that are going to multiply to give you a 24. Comes to mind to me is 6 times 4. You might have said 8 times 3, right? You might have thought 12 times 2. You can go any way you want to, ladies and gentlemen. You're still going to get down to the exact same prime factorization that I did. 6 can be broken down into a 3 times 2. 4 can be broken down into a 2 times 2. So that is now going to be the prime factorization of 24. Now, we're not really doing prime factorization. This is just a good little exercise to kind of get the juices flowing, have a couple small wins before we get into the real good stuff. And trust me, I got some good problems for you. So let's go through actually something that we might actually do when we are factoring, and that would be listing out all of the factors of a number. So when we're wanting to list out all the numbers in a factor, we don't want to just start with any two numbers that we know evenly divide into it. What I always like to do is start always with the number and 1. So I could say 81 times 1 works, okay? Then what I simply want to do is start going to, all right, well, what about 2? Is this an even number? No, it ends in 1, right? So 2 does not divide into it. Well, what about 3? Well, I know 3 goes into 60, and therefore that's going to have a remainder of 21, which 3 does divide into. So 3 goes into 60, that's going to be 27 times. 27 times, and so 3 times 27. So we have a 27 times a 3. 34. Let me just check one more number. I thought about this. No, that's not going to work. And then obviously, hopefully you probably recognize a 9 times 9. Okay, so these would be all the list of factors. And again, when we get into our factoring, that's something we're going to want to do. What about 50? Well, you could, again, 50 times 1. We know it's even, so we know 2 goes into that. Well, that's going to be a 25 times 2. And then we go 4, 6, 7, 8, 10. And you could do 10 times 5, right? So we could do 10 times 5, and it looks like that's going to be the list of everything I got. And again, I always like to start with the highest and then kind of work low. So high, down low, and then you kind of stick the lowest here and going up, and then you kind of get to this kind of middle point. And again, this will be something that we're going to practice now because you're going to see the fruits of this throughout this course. And then the last thing I just wanted to mention, I threw this one in here. I'm not really sure why, but this is a prime number, guys. This number cannot be broken down any further. So now that you have this foundation all ready to go, let's get on to the next lesson. Cheers. All right, let's get into some multiplication, not factoring yet, because before we get to factoring, you need to understand why it is we want to factor, why it is we need to factor. And one of the important things that I want you to kind of realize is when you have a product that is providing you with the area of a rectangle. See, when I say 3 times 4, hopefully you know the answer is 12, right? But if you look at this, if you take those 3 and 4 and you use them as like a length and a width of a rectangle, 12 represents the area of that rectangle. This is going to be very important because when we're given a number, right? And remember, we want to factor it. What we're trying to do is take that number and rewrite it as an expression, right? As a product of an expression. So what that means is when we multiply, we get the area. But when we are factoring, what we're technically doing, we're given the area of a rectangle, we're trying to find the sides of that rectangle. Now, when you have 34 times 43, this is not something that I learned when I was in elementary school, but I think it is something very, very important. And especially for even like my daughter and understanding the number sense of how to multiply, 2-digit numbers. I had an algorithm and we just followed it. And I didn't really understand why we're using the algorithm or how it worked. I still remember it because it was ingrained in me, but I think it's really important. If we use this concept of to multiply is to find the area, then what we can do is kind of visualize, well, how can I break this up? 34 times 43, I have no idea what that is. However, by breaking this down into a 30 plus 4 times a 40 plus 3, I can get a better understanding of how to represent this multiplication. And actually, I need to rewrite this. Okay, so now what we're gonna do is rather than just use the number 34 on one side and 43 on the other side, that's not gonna be really helpful. But what if I did 30 over here and 40 over here? Those are kind of big numbers, so we'll leave that there. Then I have 30 plus 4, and then I have 40 plus 3. Okay, now obviously you don't really need the plus, I'm showing you that that's how that's broken down. Now what I can do is rather than trying to find the area of one big number and kind of using that algorithm, I can break this down. I can find the individual areas of each of these rectangles and then add them all together to get my product. 30 times 40 is going to be 120. 30 times 3 is going to be a 90. 40 times 4 is going to be 160. And 4 times 3 is going to be a 12. So now if I want to find the area of multiplication on this, I can do a 120 plus 90 plus 160 plus 12. So let's go ahead and do this. 120 plus 90. And again, doing math in your head is going to be so important for factoring. That's why we're going through some of these examples. I need you to build up this strong foundation. 120 plus 90 is going to be 210. And I might make a mistake too, so be careful. It's going to be a 210 plus 160 is going to be a 370. And then 370 plus 12 is going to be a 382. All right, so now let's get into a little bit more abstractness, and that's going to be answer. So what about when we have something we can't visualize, we can't see because we don't know what the value is? What about when we have like a variable x? Now again, you could use anything a, b, c, y, z, w. W is a good one. What do? Well, we're just going to follow the same rules that we did with numbers, and we're just going to represent it. It's just going to be a little more abstractness because we don't know how big x is. X could be a fraction, it could be 1/2, or it could be 10,000, right? But if I want to find the area here of 5 times x, that is just going to be 5x, right? The product of your lengths times your width. Now over here, what about when we add some things to our variables? Well, again, kind of think about this. We have a 5 times an x plus 1. Again, we can do just like we did over here. We can break this up. Let's find the rectangle, or the area of this rectangle, 5 times x. We already know that's 5x. Width of this angle, 5 times 1. Well, that's just going to be a 5, right? And hopefully you're familiar with the distributive property. 5 times x plus 1 just equals a 5x plus 5, right? So I just want you to be able to visualize this in a terms of an area because yeah, once we start getting into variables, things kind of get a little bit confusing. Now, what about an x minus 1 times x plus 1? And again, I'm going to use the same method for these two to kind of represent this. What I'm simply going to do is break this up into 4 quarters. I'll just use 1 as x plus 1 on top and x minus 1 on the bottom. And again, using the idea that I did over here, x times x is going to be an x squared. X times 1 is going to be an x. X times negative x a -1 is going to be a negative x, and -1 times 1 is going to be a -1. Now, when you start to compute this area, over here there's nothing really we could do, right? 5x does not add combined with 5. Here, though, you can see we have a negative x and we have a positive x, right? And so what I want you to be able to see here is that those are going to combine to give you a 0x, which is just 0. So the final answer in this case is just going to be a x squared minus 1. Now, if you've maybe watched some other videos online, you can also maybe see that if we were to say, like, here's 1 and 1, and this would be x and then x, what we want you to be able to see is when I take this x squared, or x minus 1, x plus 1, so if you took like an x and you say minus 1, you could take this box and rearrange it, and you're going to get the same, like if you take this and put it down there, you have the same area, right? So if I take this x squared minus 1, you can see that it's going to give you that exact same area. So there's a much better illustration that they have on YouTube, but I thought it was nice enough to go ahead and include for in and around here. So, all right, that is number 2. That is at least the visual understanding that we're going to get here. I want to elaborate a little bit more on distributive property into the next video, so therefore you'll be all set and ready for factoring. All right, distributive property. I know, we still have not got to factoring, but I'm telling you, this is probably one of the most important lessons I want you to be able to visualize what we're doing so you can start to see why it is we're trying to factor and what we are looking for. I kind of forgot some parentheses here. So what we need to do is remember the kind of 2 rules for distributive property. If I have A times B plus C, remember this A needs to multiply by the B and the C. So this will be AB plus an AC. And then furthermore, yeah, we'll get to that. But what I want you to see here is factoring is basically the process of going from here to there, right? So we're going to practice going from here to here, but what I want you to be able to see is each and every time that I apply distributive property to each of these problems, what I want you to see is look at the answer and kind of look backwards, kind of follow that process backwards, because that's where students get hung up with factoring. When we get into the next lesson, we're going to do factoring. We're going to get right into it, right? And I have some lessons, I have tons of example problems, but I want you to be able to see we're working forward. Practice or factoring is going to be the process of working backwards from the distributive property. So in this first example, I have 3 times x minus 2. We're going to multiply 3 times x and 3 minus 2. So therefore, I'll have a 3x minus a 6. And again, remember what I said. If I wanted to factor 3x minus 6, what would that look like? It would look like this. 3 times an x minus 2. We'll talk more about that later. But I want you to be able to see, again, I have a monomial times a binomial. I need to multiply everything times everything. Remember, numbers multiply by numbers, variables multiply by variables. So therefore, this is going to be a 6x squared and a 2x times 5. I can only multiply the 5 times the 2, so it's going to be a positive 10x. Now we get into a trinomial. I don't have anything for a trinomial here, right? But the distributive property still works, ladies and gentlemen. What we're simply going to do is multiply the 4 times everything and the x times everything. You could also use FOIL. You can use the FOIL phase. There's a lot of techniques that we use to help students remember. But this is about factoring, so I'm hopefully assuming that you probably already know this. I just want you to visualize what happens when we multiply a binomial times a binomial that looks something like this. Because there's something interesting about this. It's the exact same numbers, except one's negative and one is positive. So negative 4 times x is a negative 4x. Negative 4 times 4 is going to be a negative 16. X times x is going to be a x squared. And x times 4 is going to be a positive 4x. So the one thing I want you to recognize here is when I go ahead and simplify this, oops, sorry, that's a plus x squared. When I go ahead and simplify this, I can say, well, I have an x squared, right? What about my x's? Well, negative 4x and positive 4x, those are going to add to 0. So I don't have any x terms. And then I have a negative 16. That looks very similar to that example I showed you with those little boxes. Remember the x squared minus 1? This is going to be an x squared minus 16. What about a problem over here? So again, just follow the same steps. Now, typically, I always like to multiply the first 2 terms first. That's going to be our FOIL, so we do first. So 2x times a 5x is going to be a 10x squared. And then we do first outer, so we do 2x times negative 1, which would be your outer terms. 2x times negative 1 is going to be a negative 2x. Then we do our inner. Negative 1 times 5x is going to be a negative 5x. And then we do our last, so we do inner, last, -1 times -1 is going to be a +1. Now, the big thing that happens to students, and the reason why I had to spend some time doing this with you guys, is because when I teach factoring or I make a video about how to do factoring, it is like, without a doubt, students will always ask, where'd this number go? Like, what happened to that number? Like, how to just eliminate? Nothing is being eliminated, ladies and gentlemen. When I go to and simplify this, right, the -4x and the 4x, those added to 0, right? I didn't eliminate, I didn't just like poof and it's gone. But when I combine them, when I simplify them, that is how I got the 0x, or no middle term. Over here, when I go to simplify this, -2x minus the 5x is a -7x, right? So when you go to simplify there, these are the only two terms that I can go ahead and simplify. I can't combine everything with the 10x squared. I can't combine anything with the 1. These two terms, though, can simplify. So my final answer is a 10x squared minus a 7x plus 1. And guess what? We're going to learn how to factor from here to there. Sometimes you can do it in your head, but this might be a little bit difficult, but I want you to be able to see. This is very, very important because we're going to get to it. So if I don't study it, if I don't teach it now, then when I'm teaching factoring, I have to go back to it and be like, oh, here's how this works. Notice a 10x squared minus 7x plus 1. If I was to work my way backwards, notice how -7x, I can break that up into a -2x and a -5x. Then I can factor things out. It's just a very important concept of this idea of distributive property, and factoring is just going to be the reverse of that. Now, in the last one, I threw in 3 terms, because it's important for you to recognize when we need to do distributive property, we want to work one thing at a time. So I have a 2 times x minus 1 times x plus 2. Now, thankfully, multiplication is cumulative, so it doesn't matter which one you do first. I would just maybe recommend doing your 2 binomials first, and then whatever scalar you have, then to go and do that. Or whenever you have like 3 binomials, if you're moving on to something more advanced, just pick 2 at a time and then multiply everything by the third one. So I'm going to do 2 times. Now let's multiply this out. X, now I'm not going to show any lines here. We're going to kind of pick it up. X times x is an x squared. X times 2 is going to be a +2x. -1 times x is a -x. And -1 times 2 is going to be a -2. Now, if there wasn't a video that was a little educational, I would probably simplify that in my head and write it down. But I don't know where you're at, so that's why I'm going to work it in a little bit slower. So x squared, let's see, plus x minus 2. Now I can apply my distributive property. So we're doing a lot of work here. And that is going to give us a 2x squared plus a 2x minus a 4. And the reason why this is important that I want you to be able to see is when we're factoring, one thing we're always trying to do is trying to say, all right, is there anything in common that all of my terms have that I can first factor that out? And again, when I say the word factor, I'm saying rewrite the expression as multiplication. See what happens here? I multiply the 2 times each and every one of these terms. When I'm given this problem and I want to factor it, what I'm basically doing is dividing each of these terms by 2, because all of these terms share a common factor, right? Remember first video? They share a common factor of 2 because 2 is divisible into each and every one of these terms. So if I divide out a 2 and rewrite it as multiplication, I can rewrite it like this. Then I would have to go into my factoring techniques of trinomials. Notice how I broke up the x into a 2x and a -x. And again, how am I going to do that? Well, we're going to learn that in the upcoming videos. But I just want you to see this process, or I want you to start visualizing the idea of what we're trying to achieve with factoring, going from this term going in the reverse of the distributive property. And guess what, ladies and gentlemen? It is now time to get into factoring on the next video. All right, let's get into it. Now, in this case, this factoring process is going to be factoring out the GCF. Now, in the first 2 examples, I don't really have factoring out a GCF. We just have some boxes with an area inside. But again, that's to reinforce what happened in the first couple of videos. And if you're one of those students that said, oh, he's not teaching about factoring until this video, let me just skip ahead, this is not gonna do it justice. So please make sure you go back to those videos, watch, understand what I'm trying to have you understand before you get to a video like this. Because there's something important that I want you to understand. Remember, I talked about factoring as the process of rewriting an expression as a product. When you think about the product as an area, factoring is the process of rewriting what are going to be the sides that are going to make that area. Now, the confusing thing about question number 1, and the reason why I wanted to do it, is there's actually multiple correct answers, right? We could do 8 times 4, but that's not the only example. So kind of going back to that original first video, what I want you to understand and what's so critical for you to understand when you're doing factoring, and something you're gonna do in your head or write them down, is to understand what are the numbers, what are the factors that make up your number. So 32, we could have 32 times 1, right? We talked about that. We could do a 16 times 2. We could do a 8 times a 4, and I believe that is going to be all that we got, right? So there's 3 different factors. So again, any one of these would have worked. I just chose an 8 times 4, But guess what? If I wanted to rewrite 32 as my side lengths, I could have done 32 times 1, 16 times 2, or 8 times 4, right? There's multiple correct answers. And again, you'll see what I'm talking about here when we get to the next video. We're going to talk about the factors and how to factor trinomials. But for right now, I just want you to see that we need to understand the factors, what makes up a number, to understand what the side lengths, possible side lengths could be. Now, in this case, I have a 4x as the area. And if I was just going to rewrite this as a product, I don't have as multiple choices that I have here. I can just rewrite this as a 4 times x. And that's really about all the options that I have, right? At least sticking with integers, okay? We're not going to get into fractions, stuff like that. We'll stick with integers. Those are going to be my options. Same thing over here. We want to deal with integers, no fractions, right? You with me? Hopefully you're with me. Now we're going to start getting into the interesting thing, because this is the one that really I wanted to get into so we can understand these two problems. Because in reality, I think we could all agree, 3, 4, and 5 is really what you're going to be most likely seen on tests and quizzes and homeworks, and for you to understand. It's also what majority of the practice problems that you're going to be practicing in this course are, as well as the quiz. So let's focus on these, but we need to understand what we and why we did stuff over here. So 6x plus 6. What side lengths could I choose? It's a very good question. I don't know. Well, sometimes we think about this and we say, well, I see a lot of 6s. So what about if I made one side a 6? What would I need to multiply by to get a 6x plus a 6? Well, you might say, well, 6 times what is 6x? You can say an x. 6 times what is going to give me a 6? Well, that would be a positive 1. So therefore, I could rewrite this box with an area of 6x plus 6 to have the side lengths of 6 times a 6x plus 1. Now, I know sometimes that gets confusing. So remember last video we talked about the distributive property? Rewrite it, right? If I know that this times this gives me this area, let's write it, 6 times x plus 1. Does when I multiply this using a distributive property, do I get a 6x plus 6? Yes, I do, okay? So one thing that I want you to look at when you're trying to identify these side lengths is a lot of times we talk about like factoring out or dividing out. Look at 6x plus 6. What is the one number or term that they have in common? They both don't share an x, but they do share in 6. So when you bring out the 6, algebraically, it's like you're dividing each term by 6. When I bring out the 6, what am I going to be left with? 8x plus 1. That is going to be my other side length. Now for these next two videos, I'm going to be a little bit more abstract. I'm not going to do the box. But if the box helps you, then rewrite it, okay? So now let's look at this next example. Kind of like pretend this is in the box. What do these two terms share? What do they have in common? What is what we call the greatest common factor between these two? Now, when you look at this, you can say, well, 7, greatest common factor of 7. Well, so we have 7 here. And then this, is 7 divisible into 35? Yes, it is, right? 7 divides into 7, and 7 divides into a 35. You know what, I lied, so I'm just going to bring this out. So I can factor out a 7, right? I can divide a 7 by both these terms. 7 divided by 7 is just going to leave me with a 1, right? And 35 divided by 7 is going to leave me with a 5. So that would be left over here, so I'd have a 1, and over here it'd be a 5. Now let's go and look at the terms. What about variables? What is the one variable that they have in common? Well, you can see that x divides an x squared, and x divides an x. So we can divide out an x to put on this side, and what's going to be left over? A x over here. Now notice that's multiplication. And then over here, the x is divide out, so you're just going to be left with an x plus 5. So rather than using this box, though, I want to rewrite it like this. When I divide out that term, rather than putting it on the side of a box, your teacher might be like, what are you doing? You can put it on the outside of parentheses. So I divided both of these terms by a 7 and an x, and what was left over was an x plus a 5. So let's go and do it one more time. Well, let's not use the box this time. All right. What does an 8x squared and a 4 have in common? Obviously, they don't have variables in common. And a lot of times people say, oh, well, 8, like 4 divides an 8. Yeah, but they don't both have an 8 in common. We have to choose the largest number that is divisible into both of the numbers, right? 8 does not evenly divide into 4. So the largest number that is both divided into, that divides into both of them is going to be a 4. So rather than put it on the side of a box, I'm just going to put it on the outside of parentheses. And what's left over when I factor out a 4, or when I divide out a 4? 8x squared divided by 4 is just going to be a 2x squared. 4 divided by 4 is going to be a positive 1. So hopefully you understand this idea of dividing out your common terms and then rewriting it like this. Because again, ladies and gentlemen, remember the distributive property. Last video, if you get confused, if you double check yourself or question yourself like, did I do it right? Factoring is just rewriting the expression as a product. We can always go back and apply the operation of multiplication to double check our work. 4 times 2x is an 8x squared. 4 times 1 is a positive 4. Ah, okay, whew, I'm good. That means it's time for me to get on to the next video. All right, it's now time to get into the good stuff. factoring with trinomials. This is where most students probably have the most difficulty. And if I was going to concede, I could probably just make a video on as many different of these examples as possible and just say, practice, do 100 of these and you'll be better at it. And that is true. If you do more practice, then you're gonna get better at things. However, the reason why I curated this course the way it was is because I want you to be able to understand things. I want you to have a reasoning behind what you're doing, because the reality is when you go to summer break, when you go ahead and take a break from factoring, you take another course and then you come back to another course that it has factoring, you need to remember what you're doing, why you're doing it. And otherwise you're just gonna forget. And all that time you spent practicing 100 practice problems goes away. Right? You have no reason to relate to it. So that's why I spent a lot of the time to get up to this point, and I'm not even done yet. I'm actually even gonna do one more kind of visualization understanding of factoring, right? When we have the area, factoring is the idea of understanding what are the side lengths for that rectangle. So for this example, we're just gonna focus on each rectangle at a time. So if I wanna say x squared, well, what two sides would create an x squared? Well, that could be an x times an x. What about a 3x? Well, if I already have x is gonna be representing the height, then x times what is a 3x? That'll be a positive 3. Over here, I have a width of x. What times x would give me a 2x? That's gonna be a positive 2. And then we notice that 2 times 3 has to equal 6, which in case it does. Now, that is the factored form of this. Now, technically, notice I can combine these two terms, right? So if I was gonna combine these two terms, I would have an x squared plus a 5x plus a 6, right? Because that's what happened with 5x. And so the factored form of x squared plus 5x plus 6 is going to be a x plus 3 times an x plus 2. But lucky for you, I broke down 5x into 3x and 2x, and that's what worked. But what if you don't know how to break it down? Well, that's what we're gonna do in the next video. So what we need to do is we need to focus on our last term. This is the big one. This is what we call our C. And remember, the last term is being multiplied by two other constants. So we need to figure out, well, what numbers are gonna work to multiply by 6? Forget about the negative for a second. Let's just focus on the 6. So 6 can be broken down into 6 times 1 and a 3 times 2. That's it. We only got two options. Now, notice it's negative. And what negative means is that one of these factors has to be negative, right? You can't do a negative times a negative. That's going to be a positive. Positive times positive never makes a negative. So that means one of these numbers is going to be a negative. Now, when we're talking about the middle term, what we're talking about is doing this operation. I think it's important that you can do enough practice so you can do this operation in your head, but sometimes it just doesn't work like that. I get it, especially when you're first starting out, it's sometimes hard to do. What I want you to be able to see is we're gonna try to combine these factors, one of them being negative, to give me a positive x. So since we have a limited amount of factors, why don't we just write out all the possibilities, so therefore you can select which one's correct. But the more practice you do get at this, the easier it does become to identify which would be the correct one in your head. Okay, so now what I did is I broke down my factors with one being positive and one being negative. Now, again, remember, we're trying to combine these. So we're gonna be now replacing this multiplication, because please agree with me that all of these multiplied to give me a negative 6, right? Because that's what we're looking for. We're not really looking for the 6, we're looking for the negative 6. However, what I'm gonna do is now to search for my middle term, I need to now combine these to go ahead and get a positive x. Now, technically, since one of them is negative, you're kind of finding the difference. But all right, well, we can just look about this as the addition from on there. I'll get to my tip later. So which of these add up to give me a positive x? And if you're seeing this one, then hey, you are correct. So what I'm gonna do in this example is I'm going to break this down one more step just so we can kind of see a factoring technique from here. So therefore you can kind of see how this works. This will be helpful for the next video, but I wouldn't recommend doing this for all of your factoring techniques. So just remember, these are gonna be the terms that combine here, right? This is technically a 3x and a negative 2x because that's how we got to that x. So rather than writing them inside a box, which I could do, right? These would just be the numbers of my coefficients for that box, right? That's how we get that middle term. Because remember, these two numbers give us that middle term, right? When we combine them in the area, that's how we get down to an x. Now what we can do here is we can factor out our common terms, factor out to the GCF. In this case, you can see the only thing they have in common is an x, so therefore it's an x plus 3. And then over here, you can see the only thing they have in common is going to be a negative 2, and that's going to leave me with an x plus 3. Now we factor out the GCF one more time. No, notice they both share, an x plus 3. So factor out the x plus 3, and you have an x plus 3 times an x minus 2. Now, you might say, Mr. McLogan, that was a lot of work, because doesn't the 3 here translate to the 3 here, and the negative 2 here translate to the negative 2 here? Yes, you caught me, right? I'm doing a little bit extra because this is going to be important for the next lesson. But in reality, guys, we want to do things easy. We want to do things fast. So once you take your factors that multiply to give you your C, and you identify which of those factors add or combine to give you your middle term, you can use those numbers into your final answer for factoring. Okay, but I wanted you to see this. A lot of students have questions with this. They get confused with this. So hopefully doing it on a little bit of an easier process will be helpful for you when you see it again in the next video. All right, let's do the next one. Now, I am one that kind of likes to do things in my head, but a lot of times that can get me in trouble. But there's one time that I think it's important for you to recognize, and that is going to be when you have what we call special products. And one thing I always want you to look for is when you have a coefficient of 1, or really any square number, and your last term is also a square number, what you're going to want to do is look for a perfect square trinomial. Now, the cool thing about perfect square trinomials is rather than getting factored to a factor times a factor, these get factored to one factor multiplying by itself, or one factor being squared. So let's go and take a look at 4 and just kind of see if this works. So 4, I could do 4 times 1 and 2 times 2, right? I don't want to use that letter. Now, then we're trying to see, well, what two numbers multiply to give me a negative 4? So obviously, if it's negative, if this term's negative but that one's positive, that means all of these have to both be negative, right? Because a negative times a negative is still a positive. A positive times a positive is positive. But when I need to combine them, right, when I need to do this operation and that term is negative, that means they both need to be negative. So obviously you can see negative 4 plus negative 1 is a negative 5. So this is my only answer. Notice how these two numbers are exactly the same, negative 2 and negative 2. Now going through my understanding of going here to here, I can rewrite this as an x minus 2 times an x minus 2, but in mathematics, we prefer to rewrite that as an x minus 2 quantity squared, right? So that is going to be your simplified version. Always look for, when you have your last term is squared and your first term is squared, always think of factors that would be exactly the same that would work. I always like to start with that first. And I always like to start with that too when we have something that has a factor term, but we're not dealing with trinomials. In this case, we have a binomial, and we don't have anything in common, right? We have an x squared minus 4, 9, so I can't factor out the GCF here. But one thing I can do is recognize that I have a square number. And again, my coefficient over here is also a square number. So rather than looking for a perfect square trinomial, what I want to do is look for the difference of two squares. And again, what's really happening here is I'm lost my middle terms. That means my middle terms add to 0. That means one has to be positive, one has to be negative. So what two numbers would add to give me a 0? Well, that's going to be two numbers that are exactly the same. One positive, one negative. So what two numbers that are exactly the same give me a negative 49? Hopefully you got this. This is a negative 7 and positive 7. So doing this stuff in my head, I can now get a x minus 7 times an x plus 7. And voila, we got the difference of two squares. Last example. Whoa, you're only going to do one example? Or where did this 2 come from? How does this impact it? Does it impact it? Can I just do what two numbers multiply, give me 8, add to give me negative 10? Nope, can't do that. The process I'm talking about working here is only going to work when my a, the coefficient of my x squared, is equal to 1. So there is a way to factor it when we have a 2, a 3, a 4, anything out in front. But we're going to get to that to the next video. What I want you to be able to see here is what happens with students all the time. They know that when a is not equal to 1, the factoring process is a little bit more complicated. It's a little bit more confusing. So when they see that, they just give up. They don't even give it a shot. But remember the video I talked about the GCF, factoring out the greatest common factor. Always look to see, is there something all of these terms share that I can divide out first? And you recognize that all of these terms can be divided by 2. So guess what? Let's factor out the 2. That's going to be leaving with an x squared minus a 5x plus a 4. All right, we're back to 4 again. Now again, this is a positive 4, so I have a positive 4 and I have a negative 5. Remember we talked about this right up here. So we have that negative 4. Remember, negative 4 plus 4 gives me a negative 4. Negative 4 plus negative 1 gives me a negative 5. So those are going to be my two factors. Just making this a lot easier. Look at how easy I'm making this for you and for me. I don't have to make up or come up with new problems. But now you guys can see I have a factored form. It's going to be two terms or two expressions and then multiplied by a scalar. But I think we all know what time it is. It's time now to learn how to factor when there is a 2 and it cannot be factored out. That is all going to come up in the next video. All right, ladies and gentlemen, let's get into factoring when a is not equal to 1. This one's gonna be fun. And what I'm gonna do, because I really want to share with you all of much knowledge as I possibly can, I am going to go through 3 different techniques that you can follow. This is gonna probably actually give me the most advanced, the most helpful, and the one I'd rather you focus in on. However, we know that once things kind of get a little bit more confusing, we start dealing with bigger numbers, we kind of want to follow a algorithm or some kind of step-by-step method. But the reason why I start with this one is because, you know, as teachers, sometimes we like to get confusing, more confusing than we really need to be. And while I think it's important for you to know how to factor when a is not equal to 1, the reality is that majority of the factoring when a is not equal to 1 that you're going to be like providing, or at least I see in calculus and for even from upper level mathematics, is going to be stuff you can do in your head. It's not going to be crazy numbers, but for whatever reason, we like to torture sometimes students. I apologize for that, being a teacher myself, with some more difficult examples. But in reality, guys, what we talked about last video, or what I wanted you to see, the middle term is all about combining those 2 squares, right? If you remember when I had that first example up here, the middle term is all about the combining. So we're not really gonna be focused with that. What we're gonna be focused with is the first and the last 2 numbers. And one thing I want you to be able to understand is that when you're factoring a quadratic trinomial, we know it's going to be factored into a product of 2 binomials. So a lot of the stuff we can do in our head. Majority of the problems that you're gonna get in your class, you can do in your head. It takes a little practice, I understand that, but I'm gonna have some examples, practice problems for you down below. Majority of them are gonna be relatively simple because I want you to get familiar with doing the simple stuff rather than trying to memorize these long algorithm step-by-step examples I'll do in these 2. But whatever works for you, stay with it. I always tell students, whatever you know how to do, then do that, right? But when you have something that's timed, like a final exam, SAT, ACT, you wanna make sure you can do things efficiently. So, rambling on, sorry. All right, so I know that my first 2 terms that I multiply, remember we're doing reverse FOIL, is gonna give me a 2x squared. Well, keeping with integers, I know that has to be a 2x and an x, right? We're not doing rocket science here. And then to give me a -1, I know my 2 numbers that I'm going to multiply are going to give me -1. Well, what are my options? 1 and -1, right? I don't have any other crazy options to go with here. So one of them has to be 1, one has to be -1, or 1 and -1. Which one is it? Well, what you need to do is look at the combination of your middle and your last terms, because the inner and your outer, sorry, I should probably use that terminology, the inner and the outer are going to be what combined to give you this x. So since my x is positive, if I do a 2x times a +1, that gives me a 2x. And if I did an x times a -1, because remember, -1 times 1 has to give me -1, but you can notice that these 2 combine to give you my middle term. -x plus 2x is gonna give me a +x. Voila, this is all the math I'd be doing in my head. I'd probably do this problem in 30 seconds, but I just over-explained it for an extra minute, all right? So that is one I could do in my head, and that is the process that I do a lot of times for a problem like here. You could break this up into a 4x, and a x, and a 2x, and a 2x, right? And then you start thinking of, all right, what 2 numbers multiply to give me -15, and start doing some multiplication with your outer and your inner to be able to see what's gonna line up to give you a -7x. It takes practice, and I know a lot of you don't like practice, a lot of you don't like to do the mental math, but I'm telling you, it doesn't take much for you to start being able to realize and start seeing the patterns and having that foundation with a strong number sense, which we started this course on, that you start to get more comfortable. But let's say you're like, Mr. McLogan, I just need some solid tips to be able to factor. I don't want to be able to do this stuff in my head. I don't want to be able to do it quickly. I just need to know how to get the right answer because I don't have a calculator or a phone when I'm taking a test. Here's a couple methods we could do. The first one is going to be what we call the AC method. So what you're going to do is you're going to take your A and your C, that is the coefficient of your x squared, and your constant, you're gonna multiply them. 4 times -10 is gonna give me a -60. Then what you're gonna do is gonna take your middle term, which would be our B, and you're gonna write it right here. Now what we need to do is identify what 2 numbers multiply to give me a -60 and add to give me a 7. Now you might be saying, whoa, 60 is a big number, has a lot of factors in it, right? So why don't we ignore the 60 for a second, and let's just do that mental math of what numbers multiply to give us 60. So we have 60 times 1, right? That's even, so I could kind of divide by 2. I have 30 times 2. I can divide by 2 again. 15 times 4. A lot of students don't get this, but we know 60 divisible by 5. So 12 times 5. And then, of course, we have a 10 times 6. All right? Now, again, remember, though, this is a negative. That means one of these factors has to be negative. right? One's negative, the other's positive, or one's negative, the other one's positive. So again, in reality, rather than worrying about which one's negative, just see which ones have a difference of 7. You can see 12 and 5, right? 12 and 5 have a difference of 7. Now, do we want negative 12 and 5? Do those add to negative 7? Or does negative 5 and positive 12 add to negative 7? Hopefully you're like, dude, come on, this is easy. It's negative 12 and a positive 5. Okay, so now what do we do with this work? Well, there's two different things we can do. And unfortunately, I am a teacher. I have to show you both ways. So I'm gonna show you the box method because that was the way that I instructed or kind of taught throughout this course. And then I'll show you another way that I also instructed throughout this course. So the first way, these are what we call our middle terms. These are gonna be what combine to give us a negative 7x, right? So if I create a box, just like I did in my previous videos, I could say, here's a 4x squared, here's a negative 15, and these are gonna be my two middle terms. So negative 12x and a 5x, right? Remember, they are the linear terms. These combine to give me that negative 7x. That's why I added an x with them. So you say, well, Mr. McLogan, 4x, that could be 2 times 2, 2x times 2x, or it could be 4x times 8x. You are correct. However, if I put a 2 here, 2 or a 2x, 2x times what gives me 5x? That's gonna be a fraction. I don't want to do that. And I don't want to use a 4 either, right? But I could use an x, and then if that's an x, that means that's a 4x. X times what gives me a 5x? Positive 5. 4x times what gives me negative 12x? Negative 3. Ladies and gentlemen, that is going to be my answer right there. It's a 4x plus 5 times an x minus 3, right? Because remember, factoring is the process of finding the sides of your rectangle. However, there is one more thing I want you to recognize. Remember, I taught this before, and I think we'll have enough room. These are your middle terms that combine to give you that negative 7x. So you could also rewrite everything like this: 4x squared minus 12x plus 5x minus 15, right? We're just rewriting the expression. And then you could group the first two terms and factor out the GCF. What does a 4x squared and a negative 12x squared have in common, right? The GCF, they have a 4x in common. So you factor out a 4x, you're gonna be left with a x minus 3. Over here, you can factor out a 5, you're left with an x minus 3. And voila, ladies and gentlemen, when you factor out the x minus 3, again, you're left with a 4x plus 5 times x minus 3. Now, that was a way that I taught a lot of my students because it related to what we learned it worked the way that I taught factoring. So it worked within the classroom. A lot of times this is the way they learned it in Algebra 1, Algebra 2. So if I was teaching it in maybe, pre-calculus or calculus, this is a way that I could help students solve the more complicated problems, the problems they couldn't do in their head. But there's also another way that we can do it that's a little bit simpler, a little bit faster. Doesn't relate to as much, but I think you might enjoy it. So how about this? Right? I don't really want to break this down into 6 times 1, 3 times 2. That's a lot. So I could do the same thing, the AC method, and I could do 6 times 4 is going to be a positive 24. So we get the 24. Let's do 24. Okay, and then we take our 11. So we say, all right, what two numbers multiply to give me 24 and give me 11? I don't know, I still like writing things out for you guys. So we have 24. That could be a 24 times 1. We could do a 12 times 2. We could do an 8 times 3, and we could do a 6 times 4. Now, since my middle term is positive, that means both of my factors have to be positive, right? If they're gonna add, then they can't, if you had a negative plus a negative, that would still be a negative. So since we're multiplying to give me a positive 24, but add to give me 11, they both have to be positive. And hopefully you see, what two numbers multiply to give me 24, but add to give me 11? That's gonna be an 8 and a 3. So what we're simply going to do is I'm just gonna write it in factored form because we know it's a product of two binomials of x plus 8 times a x plus 3. But now, notice, ladies and gentlemen, that took the 6 times the 4. So if I wanted to go back and see, well, what would my factored form? I need to divide by a 6. But I'm only going to divide by that second term. Then I'm going to reduce the fractions. So that gives me x plus a 4/3 times a x plus a 1/2. Now, we don't really want to be dealing with fractions. We know that this times this does not equal a 6x squared plus 11x plus 4, right? So if you think about when you are solving quadratics, I can rewrite this. I can multiply back this 3 to get it off the denominator, and that will give me my final answer of a 3x plus 4 times a 2x plus 1. And remember the golden rule that I talked about, guys? If you're unsure, you're like, I don't know if I did that correctly, Mr. McLogan, multiply it back. 3x times 2x is a 6x squared. 3x times 1 is going to be a 3x. 4 times 2 is going to be a positive 8x. 4 times 1 is a positive 4. Add the middle terms, you get an 11x. You can see I'm doing my math right. All right, now last two examples. The video doesn't have that much longer, guys, because the last two examples are those relationships, right? This can be hard to do in your head. This can take a lot of time if you're doing it that way or that time. This is a cool little trick, but sometimes if you don't have a foundational understanding of why and how you're doing it, it's easy to forget. So always look for patterns, right? Now, a lot of times students will see, ooh, I can factor out a 4 of the 4 and the 20. Ah, crap, but not the 25. So don't try factoring out a 4. Ooh, I do recognize 4 is a square number. 25 is a square number. It could be a perfect square trinomial. Now, before you write it as a perfect square trinomial, I would recommend writing it in factored form to double check it first. So to look at it as a perfect square trinomial, say, all right, what is the square root, right, of 4x squared? Well, that's going to be a 2x. And since this is middle term's positive, then I know that has to be positive. Square root of 25 is going to be a 5. So is it 2x plus 5 times 2x plus 5? Well, 2x times 2x is a 4x squared, yes. 5 times 5 is 25, good. 2x times 5 is 10x. 2x times 5 is a 10x. 10x plus 10x is going to be a 20x. I forgot the x, sorry about that. So you can see we can rewrite this in factored form of a 2x plus 5 quantity squared. All right, last but not least, you can see here, it's a binomial, automatically binomial. It's like two options, factor out the GCF or difference of two squares. And again, I recognize here, my first term, or this first term here is a square number and a square variable, and this is a square number. But again, since there's only two of them, I can recognize, is it gonna follow the form of a minus b times a plus b? So again, saying this, what number multiplied by itself is gonna give me 81? That's how I got the 2 over there. Well, that's gonna be 9. What number multiplied by itself gives me x squared? That's x, right? And then 10, what two numbers multiplied to give me a negative 10 but add to give me 0? Well, that has to be a negative 10 and a positive 10. 9x minus 10 and 9x plus 10. Voila. And there it is in your factored form. Now, ladies and gentlemen, we have covered everything from our factors, or from factoring, from the very basic to understanding, to factoring trinomials, factoring binomials, to even factoring when a is not equal to 1. And I feel like once you guys get your practice done and you check your understanding, you're gonna have a good foundation. But the reality is there's still gonna be some problems that are gonna trick you. They're gonna mess you up. That's why I wanted to include one more video for those of you that kind of want a little bit more of a challenge, or to just make sure that your teacher is not gonna confuse you when you have to be assessed on your own. So if you're ready for that video, get some practice, work on these, but then go ahead and check out the factoring with fractions. All right, fractions. Nobody likes fractions, so let's do some examples, because I feel like this can be very, very helpful for a lot of students, because they see a problem with fractions and they kind of immediately just give up. Like, I'm not even gonna try this, this is too hard. So let's try to make fractions digestible, all right? Now, if you need to factor something and you have a fraction, factoring means rewriting expression as a product. So if you remember this idea of, remember the first example, I think I had like 5x plus 5. And we're like, all right, you gotta factor out. There's one of these side lengths has to be something, right? And we were only talking about integers. We weren't talking about fractions. So you say, well, they both share 5, so I can factor out a 5, right? And therefore that was left with an x plus 1. Now, the problem comes into is, what about when you have nothing in common? We're gonna look at this. How do you rewrite this as a product? Well, again, technically think about this. When I'm factoring out this 5, what I'm technically doing is dividing both these terms by 5. So if I wanted to create this, if I have this as a 1/4 x minus 3, if I'm gonna say I want this to be 1/4, right? Well, divide 1/4 x by 1/4, that's gonna be x. Well, what happens here when I divide 3 by 1/4? How do you divide 3 divided by 1/4? A lot of times people remember a little trick here. I don't like that. Let's do 3 divided by 1/4. Let's write it this way. I don't want to divide by fraction, right? I want to get rid of this denominator. So what I'm going to do is I'm going to multiply by a reciprocal, because any number multiplied by a reciprocal is going to be what? But remember, you can't just take a fraction and just multiply some number on the bottom without multiplying it on the top. So 3 times a 4/1 is going to equal to a positive 12. I'm sorry, not a positive 12, a negative 12, right? Because you're dividing a negative 3 divided by 1/4. That's how I got the negative 12. But again, that is now going to be my factored form. 1/4 times a x minus a 12, right? Keep, change, flip, whatever else. I just like looking at it that way, but it's important to recognize that you can factor out fractions, right? You can factor out your fractions just like you can do with your integers. It works. The next thing. What about looking for your special products, ladies and gentlemen? Hey, first term is a square number. Second term is a square number. What do you mean they're fractions? Yeah, it's just a square number under 1. Square number under 1. So again, It's negative, it's a binomial. Does this follow the difference of two squares? Well, what would be the square root of if this is 1/4 x squared is a squared term, right? What you can do, I didn't show this actually before, so this is really good you stayed and watched this video. If I say 1/4 x squared is equal to an a squared, well then what does a equal, right? Kind of what is like the square root of that? Well, that's gonna be a 1/2 x. If 1/49 equals b squared, what would be b? It'd just be 1/7. So I can rewrite this in the factored form of 1/2 x minus 1/7 times 1/2 x plus a 1/7, right? It follows the a squared minus b squared, or the a minus b times a plus b product that we talked about, or that we saw with the difference of two squares. Now, what about when you have trinomials with fractions? Well, if I don't have square numbers, then I'm just going to get rid of those fractions. How do you get rid of fractions when you have them, or how do you get rid of numbers that are in your denominator? Well, you multiply by the number in the denominator. So I'm going to multiply everything times 6. Everything times a 6. All right, by multiplying everything times a 6, what that's going to leave me with, now again, follow me here, where we need to just remember we multiply everything by 6. So when I multiply everything by 6, I now get a 6x squared minus x minus a minus 1. Okay, now I don't have fractions. Now I can go back and factor. And notice this is a pretty simple one, right? I can factor this in my head, 3 and 2 or 6 and 1. I think 3 and 2 is going to be a better choice. So I'm going to do a 3x times a 2x. I need to multiply to give me -1. How do I get a negative x here? I'm thinking -1 here, +1 here. I just did the math all in my head, right? What I technically did in my head was 2x times 1 and 3x times -1. That's a -3x, that's a +2x. Those add to give me a -x. Now, ladies and gentlemen, is that my factored form? No, it can't be your factored form, right? You don't have any fractions in this case. So what we need to be able to look at is say, well, how do we go from here to what we needed to in our fractions? Well, again, just like how you thought about, we got to go back and we got to divide by 6. So we multiplied everything by 6. Now what we need to do is divide by 6. So you can think about it like this. Divide by 6. Now, remember though, you can only divide one of these terms by 6, right? It's not going to work in both ways. So you can't divide it into both these terms because these two expressions are multiplied by each other. So I'm just going to divide this one here. So therefore that'd be a 1/2 x 1/6 plus a 1/6 times a 2x minus 1. And voila. Now you can go ahead and multiply everything back through. 3/6 is going to be a 1/2 x that we had, and that's going to give me my x squared, and everything else will go ahead and factor out from there. All right, let's go and take a look at the next one. Where in this case, I have 1/2 x squared minus 3/2 x plus 9/4. Every single thing has fractions. Oh, man. Okay. So we need to get rid of the denominator. Now here, I have two different denominators. I have 2 and 4. So I need to find the largest number that 2 is going to divide to and 4 is going to divide to. Hopefully you recognize that number is going to be a 4. So I'm going to multiply everything times 4. When I multiply everything times 4, I'm now going to have a 2x squared minus 2 divided by 4 2 times, which is going to be 2 times -3, which is a -6x plus a 9. Okay, I think I can still work with this. I have a 2. I can probably do this in my head. Let's kind of talk it out. That's a 2x plus 1. Now 9 can either be a 9 times 1 or a 3 times 3. Well, if I do 2 times 9, that's 18. That's a big number. That's going to be really hard for me to get a 6, right? And if I did 1, that's not really going to get to a 6 either. Well, actually, they both have to be negative. No, that's not going to work. So what about if I do a 3 and 3? Well, since they both multiply to give me a +9 and add to give me a -6, that means they both need to be negative. And therefore, guess what? The only option I have, ladies and gentlemen, what did I do there? Only option I have is 2x minus 3 and an x minus 3. So now, just remember though, this does not multiply to that, right? I divided everything by 4. So now I need to divide one of my factors by 4. I'll just go ahead and do this one by 4. And therefore, I'll be left with a 1/2 x minus a 3/4. And then over here, I'm going to be left with an x minus a 3. And we can just go ahead and double check if we were to multiply this. Yep, that'd be multiply across 9/4. Look good. In my middle terms, I'm assuming I did my math right. Last example. What do you notice? I'll tell you what I notice. I notice a square term. Just like a square term there and a square term there. I also notice that's a square term as well. So I don't know if it's a perfect square trinomial, but I'm going to test it out. And so if it is a square trinomial, it's going to be 1/5 x plus 2 times a 1/5 x plus 2. Now, here is the kind of key to be able to see if it works. To see if you have a perfect square trinomial, you're going to multiply your 1/5 or your outer or your inner and your outer. So it'll be 1/5 x you're going to multiply it times the other number 2, and then you're going to multiply it by 2 again, because remember, there's your 2 of them. You have to do the outer and the inner. Now, if that gives you your middle term, well, then you're looking good. So this would be 4 times 1/5 equals a 4/5 x, which is exactly what I was looking for. However, I noticed a problem. My middle term is negative. So what that means is my 2 terms of my binomial also have to be a negative. So make sure you check that or case that. And then my final answer here then is going to be a 1/5 x minus 4 quantity squared.